A power supply is a piece of electrical equipment used to deliver either AC or DC voltage. This is a DC regulated linear power supply unit. It provides a range of positive DC voltages. And this is a switch mode power supply unit. It's similar to the linear power supply, but provides much better efficiency. Always make sure the equipment has been checked for electrical safety before using in the labs. Most laboratory experiments require DC voltage, so our main focus will be on this DC-regulated linear power supply. This is a high-quality, fully regulated power supply capable of supplying up to a maximum of 30 volts at 2.5 amps. It also has fixed 5-volt and 12-volt outputs at 500 milliamps each. Voltage and current outputs are individually shown on the LCD, liquid crystal displays. Output voltage is continuously adjustable via a single control from 0 to 30 volts DC. Output current limiting is fully adjustable up to 2.5 amps, again by a single control. This is output 1, which provides 0 to 30 volts DC continuously, with current limit being selectable between 0 and 2.5 amps. This is output 2, which provides a fixed plus 5 volts at 500 milliamps. Output 3 provides a fixed plus 12 volt output and again is rated at 500 milliamps. The power supply requires a 240 volts AC supply from a standard UK main socket outlet. The 30 volt output is terminated with 4mm colour-coded terminals. The 5 volt and 12 volt outputs are terminated via spring-loaded, colour-coded terminal blocks, and all outputs are overload and short-circuit protected. Connect the power cord of the power supply to the main socket outlet and switch the socket outlet on. Select the power supply output depending upon the voltage requirements of your experiment. This example shows the connections being made to output 1, giving a variable output of 0 to plus 30 volts DC. 4mm jack plug leads are used for this purpose. In this example, the free end of the red lead connects to the socket marked plus 20 volts on the circuit board, and the black lead connects to the socket marked 0 volts. The circuit's now complete. Switch on the power supply unit and check the status of the current limit indicator. For normal operation, the current limit indicator should not be lit. If the indicator is on, a current overload condition exists and remedial action is required. Changes to the test circuit or possibly an adjustment to the power supply's current limiting control may be needed to clear the overload condition. As the voltage increases, the lamp's brightness also increases. The power supply's display indicates the voltage output as set using the variable control. However, voltage readings should always be measured using a multimeter, which is more accurate, as shown here. To power down safely, reduce both voltage and current settings to 0. Switch off the power supply and disconnect the circuit.